Okay, welcome back. So we have some more exciting times with Bohr models. Last time we had looked at the periodic table and we had made these Bohr models and we kind of filled out the order that the electrons went on, and we had come up with this little chart. 2 electrons can fit on the first energy level, and that corresponded to these 2 elements. And then 8 electrons can fit on this second energy level, and that corresponded to these 8 elements. And then we came down to the third energy level, and we had 8 more electrons, and these 8 right here, and that corresponded to these 8 elements right here. And then we had 2 electrons, and that corresponded to these 2 elements, potassium and calcium, right here. And then 10 of them went kind of down below, and that corresponded to these transition elements. And then 6 more electrons went back onto the 4th energy level, and then finished out the 4th period with these 6 elements right here. So there's a definite pattern to the way the periodic table is arranged. It's arranged by energy levels and electrons. And one of the things we can see here is all the elements in family 1 had 1 valence electron. That's represented by their 1 dot. All elements in family 2 have 2 valence electrons, and that's represented by their 2 dots. All the elements in family 3 have 3 valence electrons, and that's represented by the 3 dots. All the elements in family 4 have 4 valence electrons, and that's represented by their 4 dots. And then all the elements in family 5 have 5 valence electrons, and that's represented by their 5 dots. And family 6, 7, and 8, and so on. The only exception is helium, who's over here with the other ones who have full energy levels, because it does have a full energy level. But the first period is weird. It only holds 2 electrons. So this little chart shows all the electrons that we know about that could possibly go anywhere. But we're going to cover part of it up. And we're going to deal with the part that we dealt with when we were making the Bohr models on the other page. So here's what we were working with on the other page. And on the other page, we said 2 electrons could go on the first energy level. In the chart, that's these 2 right here. When that first energy level was full, we went to the second energy level, and we could have 8 more. So when we were making our models over there, we stuck up to 8 more electrons on the second energy level. When we got it full, we said, oh, we need to go to the third energy level. So when it's full, we went over to the third energy level, and we could add up to 8 more. And we went down and did potassium and calcium, and we could add 2 more valence electrons on the 4th energy level. Now these are our valence electrons. We have electrons on 4 energy levels here, all the way down to potassium and calcium. Then we had those 10 transition elements whose electrons snuck in underneath the 2 valence electrons out here. So that's why we don't deal with them in middle school, because they skip over being a valence electron. And then we added in those 6 more electrons that were out here on the outside energy level for the valence electrons. Okay. Now, we're going to make some Bohr models. You're going to make some Bohr models. So we're not going to draw complete circles because they just get too big. So instead of drawing complete circles, we're only drawing part of the energy level like we've been doing these partial circles. So the first one asks us to make a Bohr model for sulfur. And the information we get off the periodic table is it has 16 protons, it has an atomic number of 16, and a mass of 32. We know that the atomic number of 16 corresponds to the number of protons. So there'll be 16 positive protons in the nucleus. We know that the atom is neutral. The number of protons is always equal to the number of negative electrons. So we can fill that in, and it's 16 negatives. Now to find the number of neutrons, this is when we have to subtract. So we have the atomic mass of 32 minus the atomic number of 16. So 32 minus 16 is our 16 neutrons. And we know what lives in the nucleus is 16 protons and 16 neutrons. we got to put 16 electrons on this model for sulfur. We know that first two can go on the first energy level. So we're going to add these two here. We need a total of 16, so we're not done yet. We know that 8 more can go on this second energy level, so it'll hold up to 8, so we're going to put 8 more on this second energy level. Now we need a total of 16, so we're not done yet. 2 plus 8 is 10. So when it's full, we know we can go to the third energy level. It's kind of like you read. 2 was full, so we went to the 8. Now the 8 is full, so we go to the third energy level, and it says this is like a bucket. It can hold up to 8. We need 16. So we don't need to use up all 8. We only need to add in 6 more. Those 6 valence electrons, like we looked at yesterday, are represented by the 6 dots in the dot diagram. That means that this element is going to be in family 6, okay? Because valence electrons corresponds to the family that it's in, because that's what gives it its characteristics. That's what tells us how it's going to bond, how it's going to react, its chemical properties. We see that there are 3 energy levels for this element. We know that the energy levels equals the period, so it's going to be period 3. Okay, now it asks us to make a Bohr model of sodium. So we look at the information that we find on the periodic table. Sodium has an atomic number of 11, has an atomic mass of 3. So we know that the atomic number 11 tells us the number of 11 positive protons. We also know that the atom is neutral, so that if it has 11 positives, it's going to have 11 negatives. To find the number of neutrons is when we need to use our formula. We take the atomic mass, which is 23, minus the atomic number, which is 11, and we get the 12 neutrons. Now we've got all the parts of the atom, and we're ready to make our model. First, we're going to put the 11 protons and the 11 neutrons in the nucleus. Now, our model is supposed to have 11 electrons. So we can look up here, and 2 electrons can go on the first energy level, and that's all that it can hold. So we're going to put the 2 electrons on the first energy level, and we see when it's full, we go over to the second energy level, and it can have up to 8. So we do need 8 more. 2 plus 8 is only 10. We're trying to get to 11. So we look at the chart, and the third energy level can have up to 8, because that's where we go next. And we only need 1. So there's plenty of room for it. We put it on, and we're done. 2 plus 8 is 10.
Number 2, teachers, please release your students. So we put it on, and we're done. The dot diagram should have 1 dot, which corresponds to the 1 valence electron. The 1 valence electron and the 1 dot tell us it's in family 1. Our model has 3 energy levels, so that tells us that this element is on period 3. Now let's look at how this corresponds to the periodic table. Both of these elements say that they're on period 3, so they have 3 energy levels, so they should be on the third period. All the elements have 3 energy levels. Our first one is sulfur, and we're predicting that it would be in family 6. If we look, here's family 6 going up and down as this column, and on period 3, and in family 6, is sulfur. Our sodium, we said we thought would be in family 1, I put a box around family 1, and on period 3, in family 1, right here, family 1, all these elements with 1 valence electron, is our sodium. So the Bohr model corresponds to its location on the periodic table. Or, more likely, the periodic table is arranged by the Bohr models. The first period, everything has 1 energy level, and there's those 2 valence electrons. The second period all these elements we discovered have 2 energy levels, and the second energy level holds up to 8 electrons. In this third period, we discovered all these elements have 3 energy levels, and the third energy level can have up to 8 electrons. All right, you're gonna try and make the Bohr models for the next 2 elements on this page, and then we're gonna pick up there and review them the next time we meet. So have a great day, and we'll see you later.